Good morning. Topic for today's discussion is Graham-Schmidt algorithm. It converts vectors into orthonormal vectors, which have many applications in machine learning. Suppose we have vectors v1, v2, and so on up to vn. Using Graham-Schmidt algorithm, we can convert them into orthonormal vectors u1, u2, u3, and so on up to un. The theorem goes like this, our algorithm goes like this. U1 is V1, U2 is, so these are orthogonal vectors. From orthogonal, I will explain you how to convert to orthonormal. U2 is equal to V2 minus dot product of V2 with U1 by length of vector U1. Now this is a scalar into vector U1. Now U3 is equal to V3 minus V2 into U1 by length of U1 into U1 minus V2 dot product U2 divided by length of U2 multiplied by vector U2. Right. The nth vector, nth orthogonal vector is equal to nth vector minus summation j is equal to 1 to k minus 1 Vn dot product uj by length of uj into uj. I leave it to you for expansion. Now, given two vectors, say v1 and v2, their dot product in Python using numpy module is numpy dot vector 1 comma vector. Now length of vector v is dot product of is dot product of vector with that vector. Suppose the vector v is x1 y1, dot product of vector with that vector is x1 square plus y1 square. What is the length? Length is square root of it. Okay. So what is length of vector v? Dot product of vector with that vector and square root of it. Okay. Now these inputs are enough to write a simple Python code to find out or to convert vectors into orthogonal and then into orthonormal. So I use an online Python tool for programming. You need not install anything, you can directly use it. It's a cloud resource. Import a module called numerical Python as NP. I will do it for a specific example. I take three vectors, vector 1, vector 2, and vector 3. Vector 1 is a NumPy array having elements 2, 1, minus 1. Vector 2 is also a NumPy array having elements 1, 0, 1. The last vector, vector 3, is also a NumPy array with elements say 3, 2, 0. So let us check what we created. Okay. So these are vectors. Now we are going to convert them into orthogonal vectors by using Graham Schmidt algorithm or rule. Now let u1, u2, u3 are orthogonal vectors. Okay. So for this you need the length of u1, the length of u2, sorry. You need length of u1, length of u2. For that you need to find out u1 first. What is u1? u1 is v1. What is length of u1? Dot product of u1 with u1, its square root. This is length of u1. Okay. Now then what is u2? u2 is equal to v2 minus dot product of v2 with u1 divided by length of u1, which is a scalar, whole multiplied by u1. Okay. Next, find out length of u2. It is square root of dot product of u2 with u2. Now u3 is equal to v2 minus dot product of v2 with u1 divided by length of u1 into u1 minus dot product of v2 with u2 divided by length of u2 into u2. Okay. So now you got u1 as well as u2 as well as u3. So these are the values. Okay. Now these are orthogonal vectors. Let us convert them into orthonormal vectors. Orthonormal vector is equal to orthogonal vector divided by its length. Okay. Now, un1 is equal to u1 by length of u1. un2 is equal to u2 by length of u2. Orthonormal vector, the third orthonormal vector is equal to u3 by length of u3. I didn't find length of u3, I think. Let us find out that. Length of u3 is equal to dot product of u3 with u3 square root. So you get square root by using square root method of numpy module. So this is how you find out length of u3. Length of u3 is ready. Okay. Now let us print them. Normal vector of vector 1, orthonormal of vector 1, orthonormal of vector 2, and orthonormal of vector 3. So these are orthonormal vectors. Okay. So how do you prove that they are orthonormal? You know that a vector into its orthogonal vector, a vector into transpose of that. If a vector is R, I'll write down that. If a vector is a orthogonal vector, the product of that vector with its transpose gives identity matrix. Suppose a 1 by 3 matrix is multiplied by its transpose 3 by 1. We get a 1 by 1 matrix. If it is identity matrix, you get 1. Okay, I think you understand it. Let us prove that above vectors are orthonormal vectors. Multiply un1, multiply un1 with its transpose. Okay. Check what do you get. It is 1. Okay. Similarly, multiply un2 with its transpose. You get identity matrix of size 1 by 1. Right? Similarly, you try the last one. Multiply orthonormal vector of 3 with its transpose. You get identity matrix of size 1 by 1. Is this clear? Okay. So I hope you understand it. Go through the code a couple of times or even more to understand how it works. And check this handwork also a couple of times to understand. Okay. That's it. Thanks for watching.